So mostly we'll be dealing with the trigonometric function and exponential functions. Right. So we know that we have so many, elementary functions, like they are algebraic or they may be transcendental. You haven't heard about those terms, but you might have heard about the exponential function, logarithmic functions, hyperbolic functions, trigonometric functions, so many functions, right? So we call them as our elementary functions in the complex analysis, right? So there are so many functions. We'll be discussing few of them. So one concept is exponential function, and the exponential function is defined as okay. So the function Ez, which is defined as e raised to power x plus iota y, and which is ex e iota y. So finally, we'll define it as ex cos y plus iota sine y. So that is something which is called as the exponential function. Okay, so we'll be doing few properties of the exponential function, and you might have heard about these properties. And first of all, you can understand that if you put y is equal to 0, so therefore you are left with ez is equal to ex, right? So this is something which is real complex function, and if you differentiate it, you know that is ex. And the same thing is true for the exponential function as well. As I've already told you, that exponential function is entire function, right? So this is analytic everywhere. Okay, so if you see that, you can. So few properties of exponential function I'll be discussing. If you take the derivative of exponential function in complex form, it will remain same. You know that your Ez, which is your fx, fz, can be written as uxy plus iota vxy, right? So this is your real component. Okay, and this is something which is your imaginary component, uxy plus iota vxy. So in order to prove that your fz is entire, what do you need to prove? Which we have already done by the theorem. That means it should satisfy the CR conditions, and it's all the derivatives should be partial derivative, should be continuous, right? So if you check it, what do you get? You simply take ux and uy. So what is ux? So differentiate it with respect to x. What do you get? ex cos y. And if you take uy, so that will be minus ex sin y. And what is your vx? So differentiate with respect to x. So ex sin y. And what is your vy? So your vy will be ex cos y. So now, if you can think of CR condition, these two are same and these two are negative of each other. So that means what? That your ux is equal to vy and uy is equal to minus vx. And in addition, you can think of that all these partial derivatives are continuous. So that means your function can be differentiated. They're analytic, right? And their differentiation can be defined in this way, which I probably haven't discussed. But the differentiation can be defined as this: ux plus iota vx. And what is your ux? ex cos y plus iota. What is your vx? Ex sin y. So if you think of this, this will be same as your function, right? So that is Ez again. So that's how you prove that if the derivative of Ez is nothing but Ez. That's how you can prove it, right? Are you with me on this?
Yes, sir.
So you can apply that the rules which we've discussed, that chain rule, product rules, all those rules can be applied, right? This is, I mean, this is easy to prove. Is it okay?
Yes, sir.
Okay.
Yes, sir.
So we can find the modulus of this function. We can find the argument and the conjugate of this function, that we can do. Okay. So I'll quickly come to those things. First of all, let's say algebraic properties of fz. Ez. So what are the algebraic properties of Ez that I'm gonna discuss? So that is, let Z1 and Z2 are two complex numbers. Then, so first of all, Ez E0 will be 1, as we have done in a real analysis. And if you take Ez1 into Ez2, that will be Ez1 plus Z2. And if you have Ez1 upon Ez2, that can also be written in this way. And if you have Ez1 raised to power n, then it will also be written in nz1 for all n belongs to the integers. Right? Are you with me on this?
Yes, sir.
You can prove those properties if you want to prove that. So let's say if I'll prove one of them, and you can then easily prove the others. So let's say your z1 is x1 plus iota y1, and your z2 is x2 plus iota y2. You calculate z1 plus z2, so that would be x1 plus x2 plus iota y1 plus y2. So now, if you want to calculate Ez1, Z2, so that would be, so what is your Ez1? We have already defined. So that is the definition of your Ez, right? This is the definition. So if Z1 is there, so we'll write it as Ex1 cos y1 plus iota sine y1 into Ex2, Ez1, expression for Ez1, right? Ez2, right? So if you take the product of these two, what do you get? You'll get Ex1 cos y1, Ex2 plus into, right? Let me write it in a proper way. So Ex1, x2, real part is there, and you have cos y1 plus iota sine y1 into cos y2 iota sine y2. So that becomes Ex1 x2, right? So cos of y1 cos y2 sine y1 sine y2. Okay. Plus Ex1 x2 iota imaginary part. So we have cos y1 sine y2 plus sine y1 cos y2, right? Or make a space to write it clearly. Sine y1 cos y2. Okay, so this will become Ex1.
X1 plus 2, X1 plus
Yes,
X2.
yes. Sorry. I should write it as x1 plus x2. Okay, so this will become what? This will be cos of y1 plus y2 plus iota time ex1 plus x2 sine of y1 plus y2. So that will be ex1 plus x2 cos of y1 plus y2 plus iota sine of y1 plus y2. Right? ठीक है?
Yes, sir.
Yes, you're with me?
Yes, sir.
Yes, sir.
Okay. Okay, so this will become your that's it. Okay, so you know that this is a real part of z1 plus z2 and this is the imaginary part of z1 plus z2. So ultimately we can write it as e of z1 plus z2. Is it fine? So similarly others can also be done. Right? You're with me?
Yes, sir.
Okay. So now we'll do the periodicity of Ez. So before that, we'll come to know that what is periodicity. So it is periodic function. Can anybody tell me?
So which repeats after every fixed interval.
Yes.
Sir, a function which basically repeats after every fixed interval.
Okay. So basically होता क्या है? So जैसे sin z है, that is also having a period sin x है let's say. इसका period 2 pi है. 2 pi के बाद भी अपने आप को repeat करेगा. बट द पॉइंट इज वो 4 पाई के बाद भी अपने आप को रिपीट करेगा, 6 पाई के बाद भी अपने आप को रिपीट करेगा. सो विल बी ओनली कंसिडरिंग द मिनिमम पीरियड, राइट? सो दैट्स व्हाई वी से दैट द पीरियड ऑफ sin x is 2 pi. So here what we're going to say, a complex function fz is said to be periodic, right? In domain D if there exists a P belongs to C. That means P is a complex number and should be non-zero. Okay? Such that whenever Z belongs to D and Z plus P belongs to D, क्योंकि डोमेन में तो आना ही चाहिए, तभी बात कर सकते हैं periodicity की, ऐसे बात ही नहीं कर सकते. So that's why. Then F Z plus P is equal to FZ. यही हो गया ना रिपीट वाला, जो तुम रिपीट वाली बात कर रहे थे, यही होना चाहिए. बोलो.
Yes, sir.
So every time whenever your P is a period, so any multiple of P is also a period. Okay. So notice if P is the period of f of z, then Kp is also the period of f of z for all k belongs to the integer. K has to be non-zero, right? क्योंकि जीरो पे तो ये हमेशा ही ट्रू रहेगा ना. जब भी जीरो, if you replace p by zero, then it makes no sense. Okay? Yes, you're with me?
Yes, sir.
Yes. So here we are not able to talk about that smallest thing, right? जैसे साइन में बात कर रहे हैं, रियल में तो स्मॉल की बात कर सकते हैं ना, कि pz, जब हम pz की बात कर रहे हैं, लेट्स से साइन की बात कर रहे हैं, तो 2 पाई की बात कर रहे हैं. 2 pi or 2 pi and 4 pi are comparable, right? 4 pi is greater than the 2 pi. But when we have started the complex analysis, we made a assertion. We came to know an important point, that is order cannot be defined in the complex numbers, right? So if Z1 is a complex number, Z2 a complex number, you cannot say that Z1 is greater than Z2 or Z1 is less than Z2. You can only say that either Z1 is equal to Z2 or Z1 is not equal to Z2. That's what the only thing which you can, which you can decide, right? So here, what kind of P we should choose, right? In order to make that this is a fundamental period. So fundamental period वहां तो सबसे छोटा उठा लेते थे, सबसे छोटे P की वैल्यू ले लेते थे, लेकिन यहाँ क्या करें, ये यहाँ के लिए एक अलग रूल होगा. So we'll see that. Okay. So our next important note is what? So if P lies nearest to the origin and imaginary part of Z should be greater than equal to 0, then P is called the fundamental period. Let's say if you are working in 1D, okay, so let's say you are here, and in case of sine, you know that 2 pi पे वो repeat होगा, 4 pi पे फिर repeat होगा, but you choose the minimum one, right? So you know that the minimum positive number is 2 pi. Okay, minimum means minimum positive. So then you choose the fundamental period, in that case P to be 2 pi. But let's say now your domain is complex analysis, is complex. That means you have the kind of 2D domain. So now in complex, you have this domain. Now how you think of a smallest number, you can't. But you try to make a similar, you try to make an analogy like you have done in a real analysis. So what do? You simply say that कि पीरियड लेना कहाँ है, ओरिजिन के पास. यहां भी ओरिजिन के पास है ना. और सेकेंडली क्या, ओरिजिन के जितना पास हो सके वो, और साथ में इमेजिनरी पार्ट पॉजिटिव होना चाहिए. दैट मीन्स दैट पीरियड शुड लाई इन अ अपर हाफ ऑफ द प्लेन. ओके, सो इन अपर हाफ. So that means if you have this thing, and if you have this thing, and if you have this thing, and if you have this thing, so what kind of period you want to choose? Let's say you have 4 choices of P1, P2, P3 and P4. तो कौन सी चूज करोगे? Tell me.
P2.
P2. Why P2?
Nearest.
Near origin and
Nearest
positive
or imaginary
imaginary.
part should be positive, right? So वैसे देखें तो P3 is closer to the origin, right? But its imaginary part is not positive, so we not gonna choose P3 as our fundamental period. P4 again, imaginary part is negative. P1 having the imaginary part positive, but what happens? P1 is actually far from the origin than P2, right? So our P2 is a choice for the fundamental period in this case. Okay, are you with me on this?
Yes, sir.
Okay, so now we're gonna try to find out the period of Ez. Actually, we're gonna say that the primitive period of Ez is 2 pi. That's what our claim is. Okay, the fundamental period of Ez is 2 pi iota. Okay, so let's prove it. So of course we need to prove that our fz should be equal to fz plus 2 pi iota in case where your fz is Ez, right? So that will be the period, and you know that, I mean, anything which is closer than origin, then 2 pi iota will not be the period. That's why it has to be a fundamental period. Okay. So first of all, we're gonna check it. So consider Ez plus 2 pi iota. That means this expression. Ex plus iota y plus 2 pi iota. And that will be Ex plus iota y plus 2 pi. Right? Now, this can be written as, by the definition of the complex exponential complex function, this can be written as Ex times cos of the imaginary part and iota sine of the imaginary part, and that is this thing. Okay, so this becomes your Ex, but you know that since the period of sine and the cos is 2 pi, so you can write it as cos y plus iota sine y. Are you with me on this? Yes.
Yes, sir.
So
Yes,
this is
sir.
nothing but Ez, right? So basically you have proved that your Fz plus 2 pi iota is nothing but Fz. So the fundamental period of Ez is 2 pi iota. Why it is fundamental? Because you know that anything smaller than 2 pi will change the value of this, right? So 2 pi is basically the period of cos and the sine. So that's why you will be able to reach once again at this part. Okay? Yes. You're with me? Yes.
Yes, sir.
Yes, sir.
Okay. So let's do few more questions. So first of all, I want to make a point that is note Ez is equal to W has infinitely many solutions. Right? Except W should be non-zero. Yes? देखो इसका मतलब क्या है? Can anybody tell me? इसका मतलब क्या है? क्या है इनफाइनाइट? अच्छा अब सोचो अगर ये रियल एनालिसिस में होता, लेट्स से मैं ऐसे लिख देता Ex is equal to 1, तो इसके कितने सॉल्यूशन होते?
1 ही होता सर।
अच्छा अगर मैं लिख देता Ex is equal to 2, कितने सॉल्यूशन होते?
1.
Okay, so what I'm trying to say is, so can you recall the graph of Ex? Something like this, right?
Yes, sir.
And if you put a constant around it, I mean, you are solving an equation where the other side is constant. Okay, that means let's say this, which is y is equal to 1, and let's say this, y is equal to 2, and so on. So you know that at this point, you have only one solution, right? But this terminology is not true in the complex analysis. That's what I want to say. Okay. Okay. So point I want to make is, so let your W is non-zero. So your W can be written as mod of W into E iota theta. Because let's say your W is equal to A plus iota B. So what is W mod? Root of A square plus B square. And you want to write out the polar form. So its polar form is R times the E iota theta, and R is nothing but root of A square plus B square times the E iota theta. So that will become mod W times the E iota theta, right?
Yes, sir.
ऐसा ही होता है? बोलो, ऐसा ही है ना?
Yes, sir.
Yes, sir.
Okay, so see this. So if your W is this, and you know that your Ez is what? Your Ez is Ex times the cos y plus iota sin y, right? Or in other words, I can also write it as, let's say, Ez is nothing but Ex times the E iota y. Now we want to solve this equation. Okay, so Ez must be equal to the W. That's what we want. So your Ez, which is Ex E iota y, should be equal to mod W times the E iota theta. Are you with me on this?
Yes.
Are you with me on this?
Yes.
Yes,
Okay.
sir.
So now what is your Ex if you compare? What is your Ex?
Modulus W.
Yes. And what is your E iota y? Yes.
E iota theta.
No, that is the thing. Okay, tell me. In other words, what is your y?
Theta.
That is theta plus 2k pi. Right? Why is it so?
Periodic
Why is it so?
function.
Yes. Okay, so your k belongs to the integers. So it has to be there. Right? Basically, if you solve it, so this becomes your x is equal to log of mod of w, and your y is equal to theta plus 2k pi. So that means it contains an infinitely many number of solutions. Okay, so we were solving for x and y. We want the values of x and y. So basically this k comes into the picture, and this makes that this k assures that you have infinitely many solutions. Yes, are you with me on this?
Yes, sir.
Okay, and tomorrow we'll be doing more questions on this. So that's it for today.